So this is a second example of equivalent polar coordinates. We're going to name 3 other pairs of polar coordinates based off of this. So this point is going to be our original, and we are going to plot that point and create 3 other equivalent ones that if you plot those points, it would be the exact same spot. Our angle measurement on this is going to be limited between negative 2 pi and 2 pi, because if we don't do that, technically there's an infinite amount of coterminal angles that we can put onto this. But we're looking for 3 others. So first challenge is let's plot this point. And then I'm going to draw my grid, and remember that a polar coordinate is just a bunch of circles. And so we had a radius of 5. It will be reflected. We'll we'll deal with that in a second. So I'm going to be graphing negative 5 pi over 6. So anything over 6 is a bunch of 30s, and 5 of them makes it at 150. So you're really talking about negative 150 degrees is kind of what you're talking about. And then we're going to go out distance of 5. That's why this circle exists. And then we are going to reflect it. That's what the negative does. So we are at negative 150. So a reference angle of 30. And we are going to reflect it to this side, so we have a reference angle of 30. Okay, so that's the actual point, and so that's kind of the challenge, is to get different versions of this. So what's going to happen is there's going to be, including the original, you're going to have 2 negatives, negative radii, and 2 positives. So that's just going to be kind of the case. So if you want to start with that, you can. And then we can figure it out. So, so if we had gone negative 5 pi over 6, reflected it over, that's what we're going to get. So if we did the same negative, we don't have to go that direction to get to this point before we reflect it over, because the negative is going to reflect it over guarantee. So another way to get there, instead of going this direction, we could go this direction. And so that would be a positive 7 pi over 6. And then the negative is going to reflect it over. Now we could also just do positive. So we're out at a distance of 5 and we go up 30 degrees. That's just going to be pi over 6. So that's one way to get to the positive and not reflect it at all. Or we can go all the way around the other direction. And so that's going to be a negative 11 pi over 6. So all of those 4 are going to get you in the exact same location. 2 of them should be negatives, 2 of them should be positives. It just depends on how you get to the positives or how you get to this value and then reflect it over, which is the 2 negatives. All right, so that is naming equivalent polar coordinates.